Hello. I am going to demonstrate how to do structural analysis, design, and detailing for an RCC frame structure using NirtsCAD. First, you draw the central line sketch. Using the line command, I am following that from 1,1 to 5.1,0 and to 4.5,0. Then in the Y direction, I will draw the lines at 0,4.5, at 0,5.1, at 0,4.5, at 0,5.1, and at 0,4.5. Then I will copy this. I am selecting the crossing method. Select from this point, then pick the other corner. Then I will copy this. Similarly, I will copy the lines in the X direction. Next, I will dimension it. Use the dim command, and type the letter G for the align method. Just click the first point, and then the second point. Specify the dimension location, then click continue, and click the next point. I will do the dimensioning in the Y direction using continue. This is the center line sketch of the building. I will copy this and create the middle line also. At every junction, one column is there. I am going to add columns using the structural panel in the CAD Max menu. When you click on the structural panel, the side panel will open. Go to the 3D ortho view. That will be better for inserting columns. First, I will insert a column. If you click on column, the column properties will appear. This is a rectangular column. Select the column size you want to use. I will use size 450 by 230 and pick the point. For the angle of orientation, click on this button and click on the point to which it is oriented, so that is 0 degrees. This building is ground plus 3 floors, so each floor is 3 meters, which means 4 multiplied by 3 is equal to 12 meters. With a basement height of 0.6 and a foundation depth of 2 meters, the top elevation is 14.6. Bottom elevation is 0. Place the column. The column is drawn, and now you will see the column. Now I will copy the column in the X direction, then I will copy in the Y direction. Use the copy command, select 3 columns, and copy them in all the column locations. Now let's copy these 3 columns in the Y direction. If you right-click and move the mouse, the axis directions will be rotated. Then we will draw the grade beams, that is, the ground level beams. Click on beam. This is a grade beam, so I will name it G-beam. Set the grade beam size to 230 by 450. I will pick the start point at the top of the column, then pick the end point. The start point elevation and end point elevation is 2 meters, which is the ground level. Start point supported is checked, and end point supported is checked for regular beams. Suppose it is a cantilever beam, you can remove either the start support or the end support. If you want to consider soil support, suppose the area is very hard, then soil support will give a reduced load on the grade beams. If you check this, 50% of the load on the grade beam is considered. In our design, we are not considering soil support. I will click Place Beam. The beam is placed now, and you can see it in green color. I will draw the next beam similarly. Now I will copy these beams. I use the copy command and select the last drawn beams. For the base point, select this top point. Then copy it to the other locations by picking the required top points. Similarly, you can draw the grade beams in the Y direction. Beams with the same span can be copied together to other required locations. Now all grade beams are drawn. Next, let's draw the walls on the grade beams. For this, I will select the wall tool in the structural panel. I create the walls on the G-wall layer. Pick the start point first. You need not consider any kind of intermediate columns, and pick the endpoint where the wall ends. It should be in a straight line only. Then set the start point elevation, and endpoint elevation to 2 meters. I am going to use the ground floor for parking, so the ground floor wall will be up to the basement level height, or some extra height may be fixed as 1 meter for walls. Now, place the wall. Let's zoom in there to see whether the wall is placed or not. You can verify a blue color line is there, which is the wall. I am going to copy this wall wherever I want. Use the copy command, select last, pick the base point, and copy here. Then I don't want to copy here. I want to copy here, and then copy here. Similarly, I will draw the wall in the Y direction. The color of the wall seems to be different, so I will change the color of the wall to blue using the change command, and select the color as blue. Now all walls are drawn in blue color. I am going to provide a lift and staircase in this portion, so for that I will give separate wall heights for that area only. Pick the start point, and pick the end point. The wall height for this area has to be calculated as the floor height of 3 meters, plus the basement height of 0.6 meters, minus the beam depth of 0.45. So it will be 3.2 meters height. I will place the wall here. The other side walls in that area are drawn similarly. Now all 3.2 meter walls are drawn. In this area, only a 1 meter height needs to be placed. Pick the start point, pick the end point, reduce the height to 1 meter, and place the wall. Similarly, the remaining 1 meter walls are drawn. Now all the grade beams and walls are drawn. Now I will go to Manage Layers. Here we hide the 0 layer, where the centerline and dimensions are drawn. CAD Max Structure Layer is an automatically created layer. If you want, you can delete it. I will hide all layers now and keep only the G-beam layer. Close the menu. You are now seeing only grade beams. Now I want to change this to the beam layer. Use the change command. Select all objects, choose layer, and type beam. The beam layer will be automatically created, and the objects will be transferred. Next, I will copy all of this to create first floor beams. Use the copy command, select all, pick any base point, and specify the next point as the basement height plus floor height, that is, 3.6. Now the first floor beams are created. Then I will change the previously selected grade beams back to the G-beam layer using the change command. Now I can keep the beam and column layers on, and turn the G-beam layer off. This is the first floor, or the ground floor roof level, for which I am going to design slabs. Click on the slab. This is a residential building, so I will give the live load as 2 kilonewtons per square meter, 1 for floor finish, and 1 for partition wall load. This is slab number 1. This is a two-way slab, so this will be 2. Add boundary condition 4, which is 2 adjacent edges discontinuous, as per the location. This boundary condition is correct. I will pick the corners in an anticlockwise direction from the lower left corner. That is the method to be followed for drawing slabs. Pick corner 2, pick corner 3, then pick corner 4. Set all corners to the same elevation, which will be 5.6. Then click the slab reinforcement button. The slab design parameters form appears. In this, for slab thickness, I use a minimum thickness of 150. If you give a reduced thickness, the software will work out the slab thickness for moment and deflection, and increase the thickness automatically. I will give 150 as the minimum thickness. Then for the main rods, 10 mm diameter with a minimum spacing of 100 mm, and maximum spacing of 150 mm. For long span rods, 8 mm diameter with a minimum spacing of 100, and maximum spacing of 150. I just click Apply for slab. Now, the slab is drawn, but it is not seen. Go to Manager Layer and turn off the beam layer. Now you can see the slab. Now you can copy the slab to wherever you want where the dimensions is the same. Use copy command, select the slab, pick a base point and copy the slab to the locations that are of same dimensions. Now let's create slab number 2. This is also a two-way slab. All sides are equal in the slab. Pick the 4 corners the same way as the previous slab. Keep the same elevation at 5.6 and click on Slab Reinforcement. We adopt the same parameters for this slab, so click on Place Slab. The slab is drawn. Now this can be copied using the copy command. Select the last object and pick the points. The slab is copied. Similarly, slabs 3 and 4 are created. All the slabs have been designed and drawn. The material strength used for these slabs is M25 concrete and Fe415 steel. If you want to change it, you can. Change to 20 for concrete and 500 for steel. To apply the new settings, you must click on Redesign Slabs and select the elevation filter where this should be applied. We select 0 for lower elevation and 6 for upper elevation. Say OK. Now the re-slab form appears and you can see the new concrete and steel strength as 20 and 500 here. The other parameters remain the same. Say OK. Now you have to select objects. You can select all the objects, but it will only select the slabs and revise the slab design for the 10 slabs in this drawing. The redesign for the slab is done. If you want to see the data attached to that slab, you can click on X data. Select the slab. The X data is shown. It indicates the slab number, two-way slab, live load, floor finish, light partition load, boundary conditions, and 150 as the slab thickness. After 150 is the spacing, design output, and the design procedure starts there. Slab thickness, total load, MX, MUX, MY, and MUY are all there. The design procedure is also saved in the slab itself, and it can be taken out in Excel as CSV format. Now let's draw the first floor walls. Use the wall command. Pick the start point for the walls. Then pick the end point. The elevation is 5.6 for the first floor beam. The floor height is 3 meters, so floor height minus beam thickness will give 2.6. So I will give the start height as 2.6 meters and the end height as 2.6 meters. If it is a sloped wall, you can give 2.6 and 3 meters, which will also work. Now place the wall. The wall is drawn. To draw the wall in the other direction, I use the same start point, select this endpoint in the Y direction and place the wall. Similarly, walls are drawn in the other directions. You can also copy the wall by using the copy command, selecting the wall, and placing it where you want by picking the points. Let's copy the walls in the X direction. So we have copied everything. The ground floor slab, ground floor beams, ground floor walls, and first floor walls are done. You can copy this to the other floors. Make the column layer and wall layer off, and keep the beam and slab layer on. Beams and slabs will be repeated to every floor, so you keep them on. You are going to copy this for the further 3 floors. Use the copy command, select objects. Then click the base point, and type at 0,0,3 in the Z direction, and press Enter. Type at 0,0,6 in the Z direction, and press Enter. And type at 0,0,9 in the Z direction, and press Enter. The copy process is completed for slabs and beams. Now, I am going to copy the walls, so enable only the wall layer. Use the copy command, select objects, pick the base point, then type at 0,0,3 and press Enter, and type at 0,0,6 and press Enter. You see only walls are copied. Turn on the other layers. Now I want to draw the parapet wall. Use the layer P wall. Give the start point, and give the end point. Set both the start point and end point elevation as 14.6. The wall height is 0.9 meters. Place the wall. It is drawn. If you want to see it, I will zoom in and show you. So the parapet wall is drawn. We have to draw it in the other directions also. The start point is the same, I am only changing the end point. The end point is not picked correctly, so I press F3 to turn on Object Snap. Now select the end point again, and place the wall. The longer side parapet wall is added. Similarly, you can draw parapet walls on the other two sides. To change the load for the top floor if necessary, you can change it from the CAD Max menu. Select Edit Properties, then Slab Load, to change the slab live load, floor finish, and light partition load. The load change form will appear. Apply the elevation filter for the top floor by selecting the lower elevation as 14 and upper elevation as 15. Set the live load as 1.5, the floor finish as 2.0, and 0 for the light partitions load. Click OK. For the load change command, select Objects. Since we have already applied the elevation filter, we can select all objects, and it will apply only to the top floor slabs. You will see it updated only the 10 slabs, even though 240 were selected. Others are skipped. Our development of the structure is over. Now we will do analysis and design. We will use the beam load command as the next step. I will just run the command and select objects by window or crossing. If you want to generate a starred file for analysis in starred, you can say yes here. Analysis is available in this software itself, so I will give no here. I will show the starred analysis in another video. Now the beam load is completed. After the beam load is completed, you can keep only the beam, G-beam, and column layers on, and turn off other layers, as the wall and slab loads are now transferred to the beams. You can rotate and see it in any direction by right-clicking and moving the mouse. Next, we want to do the analysis. Select Analyze from the CAD Max menu. It will ask you to select objects. You can select all items and press Enter. You can see magenta-colored joints are created. The analysis is done now. I will explain point load transfer, wind analysis, and earthquake analysis in another video. In this present example, I am going to do only the dead load and live load analysis. Let's start with the design of beams. Select Design Beams from the CAD Max menu. The elevation filter form for beam design will appear, where you can select the lower elevation as 0 and upper elevation as 15. Select all the objects. Now the beam design parameters form will appear. I will use a concrete strength of 20, and steel strength of 500, cover to the reinforcement as 25, the minimum diameter of rods as 12, and the diameter of stirrups as 8. Then click Design Beams. Now the design of beams is over. Next is the design of columns. Select Design Columns from the CAD Max menu. Select all the objects and press Enter. Now the design column parameters form will appear. Change concrete strength to 20, steel strength to 500, cover to the bar to 25, main bar diameter to 16, lateral ties diameter to 8, and minimum steel percentage to 0.8. Design for minimum eccentricity, as per IS 456. If you want the additional moment due to the slenderness effect, you can check the last box. I am checking both for this design. Click Design Columns. The column design is completed. Next, we will do the design of footings. Select Design Footings from the CAD Max menu. Select all objects. The footing design parameters form will appear. The safe bearing capacity is selected as 200, the footing type is isolated square footing, concrete strength is 20, steel strength 500, clear cover 40, and minimum diameter 10. Click Design of Footings. The design of footings is completed. You can see all the footings are drawn at the bottom of the columns. Now the analysis and design for this structure is completed. I will save this drawing in my file system. Let me give a file name and save it. Now I will show how to create drawings of reinforcement detailing for footings, columns, beam, and slabs. Go to View menu and click on 2D Top View, and zoom it to view the whole drawing. Go to CAD Max menu and pick Foot Detailing from Detailing sub-menu. Select all objects and press Enter. Pick upper left corner to place schedule of tabulated values. The dimensions of footing and reinforcement details are drawn. The footings are also grouped as F1, F2, F3 according to size of the footings. Zoom the table and see the values. The typical footing template drawing I have already developed and saved in my computer. I will import that drawing using JS-Win command in Draw menu. The template is now inserted. Let me zoom in. The inserted will contain LX, LY, total depth as TD, edge depth as ED, top size as BX and BY along with reinforcement representing along X and Y direction. The cross-section of the footing is also shown above the plan drawing with depth and placement of reinforcement along X and Y directions. The details of values of LX, LY, depth, top size and reinforcement dia, and spacing are detailed in table of schedule with grouping as F1, F2. I move the template drawing above the table. I set current layer as foot detailing using Manage Layers. Then draw a rectangle around the table. Now let us zoom all to view the whole drawing. Now I will make the layers foot D and foot detailing off. In the foot layer, I will show the footing grouping details as F1, F2, F3 within the respective footings. Now I am going to do the column detailing. From sub-menu of Detailing select Column Detailing. For select objects select the whole drawing and press Enter. Now prompt appear to pick upper left corner of the schedule of table. Pick a point on the drawing. The table of schedule of column detailed drawing is placed below the pick point.
Then zoom it to see the values and cross-section drawing of columns grouped floor-wise and similar columns named as C1, C2, C3 as required. You can see the same C1, C2, C3 names in top view of the drawing also near the respective column locations. The column detailing is drawn in separate layer named Column Detailing.
Now I will turn off the layers foot and column detailing to proceed for beam detailing. For beam detailing, grid lines are to be drawn to identify the beams from detailed drawing. From the Detailing sub-menu select Grid Line. For select objects select the whole drawing. Then prompt will appear for grid line option 1 or 2. Select 1 and press Enter. The grid lines are drawn. You will see the A, B, C encircled in X direction and 1, 2, 3 encircled in Y direction. The method of identifying columns intersecting a grid and one grid is A1 column, an intersection of a grid and 2 grid is A2 column. The beam connecting A1 and A2 is beam A1-A2, and beam connecting A1-B1 is beam A1-B1. Now I will draw beam detailing. From Detailing sub-menu select Beam Detailing. The elevation filter box will appear. Edit lower elevation as 0 and upper elevation as 6 to draw grade beams and first floor beams detailing and click OK. For select objects, select only the beams on single line from A1 to C1 and press Enter. Then specify the insertion point to draw detailing. Pick a point on drawing area. You will see the detailed drawing of the beams along A1 to C1 for grade beams and first floor beams drawn neatly. Zoom in the drawing to see the detailed drawing with reinforcement details with curtailment lengths, bar diameter, and spacing of stirrups, and cross-section of beam at midspan representing L-beam or T-beam. If some editing requires, you can change the rod details using text edit command as per field requirement. Similarly, all other beams are detailed. Now to draw detailing of slabs, turn off the layers beam and G-beam and keep slab layer on. You will see cyan color slabs in the top view. From Detailing sub-menu, select Slab Detailing. Elevation filter form will appear. Edit lower elevation as 0 and upper elevation as 6 to draw first floor slab detailing and click OK. For select objects, select whole drawing and press Enter. The slab detailing with slab no thickness and reinforcement details of short span and long span rods will be neatly drawn. You can zoom the drawing to see the details. Now we have done structural analysis, design, and detailing of all the members, such as footings, columns, beams, and slabs. To see the overall view of detailing done, you can make the layers foot detailing, column detailing, A2C2 on. You see overlapping of column detailing and foot detailing layers. Make column detailing layer off and move the foot detailing drawing downwards to avoid overlap. Then make the layer column detailing on. Now you will see the overall view of detailed drawing. You can take printouts using Print PDF from File menu by making respective layers on and off. Save the drawing using File menu. The design procedure extraction for slabs, beams, columns, and footings I will explain in the next video. With this I end this video. Thank you.